Well, this is an interesting problem now. We have the whole number 9 minus 6 3/5. Well, this is a mixed number and it's a whole number. Now we know when we're dealing with whole numbers, we block out the whole number, we do the fraction first. But we have 3/5, we can't take 3/5, there's nothing up here. There's nothing up here. Well, there is a skill that you already know that's really important. We know that we know that there's a special type of fraction where if the numerator and the denominator are the same, the fraction is equal to 1. So 111 over 111 is really equal to 1 whole. So we already know that. But what I want you to think about is exactly not the opposite of that, but the reverse of that. I can take 1, the whole number 1, and I can change it into a fraction with any denominator that I want. Like I could say 1 is equal to 17 over 17, which it is. I can say 1 is equal to 3 over 3. So I can change the number 1 into any fraction I want as long as the numerator and the denominator are the same number. Now that is an important skill in learning to subtract fractions like this, and I'll show you why. What I need up here is I need a fraction whose denominator is 5. Well, in subtraction, we learned in elementary school that I can borrow. So I'm going to change this to the whole number 8, and I'm going to borrow the number 1. But the number 1 doesn't help me. I can't put the number 1 here. But I do know that if I have to have a fraction whose denominator is 5, I can change the number 1 into 5/5. So I borrowed 1, and I put 5/5 here. Well, 5/5 is exactly the same thing as 1. So the one I borrowed, I just changed it and rewrote it as 5/5. Now I have the denominators the same, 5 and 5. So now I can subtract 5/5. 5 from 3 gives me 2/5. And now since I borrowed, the 9 became an 8. 8 take away 6 is 2. So there is the skill. I had nothing here, and I had to borrow the number 1. But I had to have a fraction whose denominator was 5ths. So I just said, okay, well, 1 can be 5/5. Put the 5/5 and did the subtraction. Good. Well, we're going to work a couple of problems like this so you'll get used to it. Okay, now let's take a look at this problem. We have two mixed numbers here, 12 and 3/7 and 8 and 6/7. Well, we're going to forget, well, we can't forget the mixed numbers here because the problem is this. I cannot take 6/7 from 3/7 because 3/7 is smaller. So I'm going to have to borrow, make this an 11. Now I'm borrowing the number 1. Well, the number 1, like it is there, doesn't help me. But if I change the number 1 into 7/7 and I add the 7/7, 3/7 and 7/7 gives me 10/7. So I had 3/7. I borrowed the number 1. I made the 12 and 11. I borrowed the number 1, and I changed it into 7/7. And I had 3/7, so I combine the 7/7 and 3/7, and I get 10/7. Now, I can subtract these numbers because the denominators are the same. 10 take away 6 is 4. So I have 4/7. That's a proper fraction. It's in its lowest name, so I'm done with the fraction part. And now I go 11, take away 8 is 3. Okay, so let me do a quick review here. The initial problem was I had 12 and 3/7 minus 8 and 6/7. I could not take 6/7 from 3/7 because 3/7 is smaller. So I borrowed. I changed the 12 to an 11. I borrowed the number 1 and I changed it into 7/7, which is the same as the number 1. And then I combined the 7/7 with the 3/7, and that gave me 10/7. Then I could subtract 10 take away 6 is 4/7, and then 11 take away 8 is 3. Good, we'll try another one here. It may take you a little bit to wrap your head around this concept, but really it's not that bad. Let's take 8 and 1/3 minus 4 and 3/4. Okay, a couple of things we got going here. First of all, the two denominators are different. So we're going to have to raise one or two of these. So let's see what we can do here. Well, I need a number that 4 goes into evenly and 3 has to go into the same number. So we'll start with 4. 4 we know goes into 4 evenly, 3 does not. Well, then what's the next biggest number that 4 goes into evenly? It'll be 8. We know 4 goes into 8 2 times, but 3 does not go into 8 evenly. So then what's the next number after 8 that 4 goes into evenly? That's 12. And we know that goes into 12, and we know 3 goes into 12. So we can raise these to 12ths. 3 times what number gives me 12? Well, 3 times 4 gives me 12, so 1 times 4 gives me 4. 4 times what number gives me 12? 4 times 3 gives me 12, so then we multiply 3 times 3 gives me 9. Okay, now I have both denominators in 12ths. I have renamed 1/3 to its higher name 4/12, and I've renamed 3/4 to its higher name 9/12. But I cannot subtract 9/12 from 4/12 because 4/12 is smaller. So I have to borrow, right? So I borrow the number 1. We know that the number 1, just the way that is, doesn't help me, does it? But what do I change the number 1 into? Well, since I have to have 12 as a denominator, I change the number 1 into 12/12. Now I can combine 4/12 and 12/12. And if I combine 4/12 and 12/12, it gives me 16/12. And now I can subtract 9/12 from 16/12. Well, 16 minus 9 is 7. So I have 7/12. That's a proper fraction, and it's in its lowest name. So I'm done with the fraction part. Now I go back to the whole number part. I had borrowed 1 from the 8, so it's a 7. 7 take away 4 is 3. So this was an interesting problem. It started out with the denominators not the same, so I had to rename these, both of these, to their higher fractions, higher equivalent fractions with a denominator of 12. But then I still couldn't subtract because this was bigger than that, so I borrowed 1, turned it into 12/12, combined the 12/12 with the 4/12, got 16/12. Then I could subtract 16 take away 9, 7, 7/12, and then 7 take away 4 is 3. Okay. Well, good. I'm going to give you one here to work on your own, so I'll be back in a second.